Start with something obvious. We rarely stay there. The moon comes up behind a row of houses or over the water, and it's enormous. And a few hours later, it's overhead. And it's a coin. Hold your arm out straight and put your thumb over it. It fits. Your thumb covers the moon. Same thumb, same moon, every time. That's a demonstration, not a measurement. But it settles the one thing we need settled right now. Whatever changed, it wasn't the moon. Your eyes don't report size. They can't. Size is a fact about the world, and all your eye has is a patch of light on the back of it. What your eye reports is an angle, how much of your view something takes up. The moon takes up about half a degree, but you don't experience angles. You experience sizes. And to get from one to the other, something has to combine that angle with a sense of how far away the thing is. Something quietly corrects for the distance and hands you the answer. You never see the raw number. You get the finished sentence. The moon on the horizon is one of the few places where you can catch it working. Here's the turn. When the moon is low, it's not merely failing to be bigger. It is measurably smaller. You're standing on the surface of the Earth, not at the center of it. When the moon is straight overhead, you are one Earth radius nearer to it. That's about 4,000 miles of difference, which sounds enormous, and at this distance is not. So the moon that looks huge is the one that's slightly farther away and slightly smaller. The one that looks enormous measures a little less. People noticed this a long time ago. Aristotle wrote about it in the 4th century BC. That's 24 centuries. The explanation that stuck longest got its most influential statement from Ptolemy in the 2nd century. The air, he said. Near the horizon, you're looking through a much thicker slab of atmosphere, and it magnifies, it doesn't magnify. The atmosphere does bend the light, and what that bending actually does is lift the bottom edge of the moon more than the top edge, and squash it by about a sixth of its height. The oldest surviving explanation doesn't just get the answer wrong, it predicts the opposite of the thing it was invented to explain, and it was repeated without much argument for the better part of 1,000 years. It's still what most people say today, which leaves the question this channel exists for. If it's not the air and it's not the moon, then what is it? And the harder half, how would anybody establish that? There's two families of answer, and the modern round of the argument dates to the 60s. One says it's about distance. The horizon comes with a landscape attached, a run of ground and trees and rooftops stretching away. And all that tells your visual system the moon is very far off. Very far off plus half a degree equals big. Overhead, there's nothing to measure against. The distance estimate collapses and the moon shrinks. The other says it's about your eyes. Rolling them upward changes how they aim and focus. A clean disagreement. Two camps, opposite mechanisms, mutually exclusive predictions. That's exactly the setup that experiments are supposed to resolve. In 1962, two psychologists, Kaufman and Rock, built artificial moons, floated them optically onto the real sky, and reported that the landscape was essential. Take the terrain away, they said. Put people in a planetarium or a dark room, and the illusion doesn't happen. In 1991, a researcher named Suzuki ran it again. In complete darkness, he got the illusion. Those two can't both be right, and as far as I can find, there's one attempt from outside either lab. In 2015, a researcher in Germany took 5 people into a planetarium in Nuremberg in total darkness, and like Kaufman and Rock, he found no illusion. It's a 4-page note. The scale had nowhere left to go. He writes it himself in the paper. The method wasn't sensitive enough to pick up changes in size between the conditions. Terrain question, the foundation of the mainstream account, rests on 2 experiments that contradict each other, and one 4-page note that couldn't have told them apart. It gets more awkward. The distance explanation says the horizon moon looks bigger because it looks further away. Ask people and most of them say the opposite. It looks bigger and it looks closer. Researchers call that the size-distance paradox. The name was already in print by 1956. And now, here's the real thing, which turns out not to be about the moon at all. How do you measure how big something looks to somebody else? You can't photograph it. The camera's fine, the moon's fine. The entire event is happening inside a person. So the obvious move is to ask. And at the moment you ask, you're measuring a sentence, not a perception. That statistic, most people say bigger and closer, is real. and it's repeated everywhere. Its source is a footnote in a paper from 1986. The author had been polling his own lecture audiences before the lecture started, asking them to write down from memory what the moon had looked like, over 500 people across 20 years. He also writes, and this is his phrasing, reports about memories obviously are poor evidence. The sentence keeps going. He says the answers didn't disagree with what he had been publishing about the moon or with lab results on targets viewed the same way. And the finding isn't in doubt. A study in 1990 ran 6 controlled experiments and got the same paradox out of pictures. It's the number that came out of that room. The finding came from the field. The flagship modern paper is smarter than the number. In 2000, rather than asking people how far away the moon looked, it used stereo depth as an indirect measure. 5 subjects in an experiment that turns on fine depth judgment. And one set of initials in the subject list matches the first author, who was testing a theory he had put forward 38 years earlier. None of this is hidden. Running yourself as a subject is ordinary practice in this corner psychology, where the tasks are long and dull and repetitive. It's not a scandal, it's just one more reason 5 isn't enough. The effect they found was large, it was consistent, and all 5 subjects went the same direction. That's not nothing. The problem is 5 people is 5 people, and I couldn't find a single independent replication in the 26 years since. Don McCready, the leading champion of the rival theory, the eye movement one, wrote in 1986 that the quantity his entire account is about, how big the moon looks in degrees, had never been published for the moon. Too small, he says, and the precision required is too fine. 40 years on, as far as I can find, that's still true. So I went and counted the field. PubMed's the main index for medical and life science literature. I reran the search the week we recorded this. 60 records, not 60 this decade, 60. Go to the biggest index I could find and search titles, and it's under 200, ever. 24 centuries of people noticing, a couple of hundred papers. When we say a thing is unexplained, we tend to hear that the answer is hidden. Often, it means something much more ordinary. It means nobody's been paid to look. Because none of the missing experiments are exotic. Run the planetarium study again, properly with 100 people, and a scale that can move, and the terrain question is settled inside a week. And the people who wrote the book on this literally don't say nobody knows. They say it's probably several things at once. They even try to weigh the parts, but that assessment is one paper from one pair of authors in 1994. And as far as I can find, nobody's gone back and measured the weights independently since. And it's still sitting there. So the next time you hear that something's puzzled scientists for centuries, the useful question isn't what the answer is. It's how many people have actually tried and what they measured it with. Sometimes the mystery really is that deep, and sometimes the mystery is an empty chair. I'm Jeff. This is where we figure out why you believe things and how we would even know if they're true.